China has recently released new images that are drawing serious attention in the global defense community. These images show a J-20 stealth fighter finished in yellow primer, which is usually seen during production or acceptance testing. And most importantly, the aircraft appears to be flying with the long-awaited WS-15 engine instead of the earlier interim engines. This is a major development because the WS-15 is the engine China originally designed for the J-20 to unlock its full fifth-generation performance potential. On January 24, 2026, Chengdu Aircraft Corporation shared several images to celebrate an ongoing flight test program involving multiple aircraft types and locations. Among these images, one stood out. It showed a J-20A stealth fighter in yellow primer, flying in what looks like a production or acceptance context rather than a purely experimental test. Analysts quickly focused on the exhaust area, where the nozzle shape appeared consistent with the WS-15 engine rather than the older AL-31 or WS-10 engines. This strongly suggests that the WS-15 is no longer just an experimental engine, but is moving toward real operational use. Earlier versions of the J-20 entered service with Russian AL-31 engines and later with domestic WS-10 engines. While these engines allowed the aircraft to operate, they limited its full potential, especially in terms of sustained supersonic flight, acceleration, and high-altitude performance. The J-20 was always designed around the WS-15, so integrating this engine is critical for the aircraft to reach its intended capabilities. This latest flight suggests China is moving beyond temporary solutions and is now focusing on scaling up production and real-world integration. The aircraft seen in the images is believed to be the J-20A, an updated single-seat version of the J-20 with several aerodynamic and structural improvements. One visible change is a raised section behind the canopy, which smooths airflow where the canopy meets the fuselage. This reduces drag at high speed and improves aerodynamic efficiency. This reshaping also creates extra internal volume inside the aircraft, which can be used for additional systems or extra fuel. More fuel means better range and endurance, especially for long-distance missions over the Pacific. However, adding systems and structural modifications increases the aircraft's weight. That means the engine must provide more thrust to maintain or improve performance. This is why the J-20A and the WS-15 must be considered as a combined system. The airframe improvements only matter if the engine can support them reliably. With a more powerful engine, the J-20A can improve acceleration, climb rate, and sustained supersonic flight, also known as Supercruise. The WS-15 engine has a long and complicated development history. Development began in the early 1990s and went through decades of testing, redesigns, and maturation before entering serial production around 2023. It is a low-bypass afterburning turbofan designed specifically for fifth-generation fighters. The engine is about 5.05 meters long, around 1.02 meters in diameter, and weighs roughly 1,600 kilograms. It uses an axial flow compressor, an annular nickel alloy combustion chamber, and single-stage high and low-pressure turbines. Its bypass ratio is around 0.25, and the overall pressure ratio is in the 25 to 26 range, showing that it is optimized for high thrust rather than fuel efficiency. In terms of performance, the WS-15 is estimated to produce between 161 and 180 kilonewtons of thrust with afterburner. Turbine inlet temperatures are believed to be around 1850 Kelvin, which is extremely high and comparable to modern Western engines. The dry thrust is intended to support sustained supersonic flight without afterburner, which is one of the key features of true fifth-generation fighters. The engine is also expected to generate more electrical power for onboard systems like sensors, radar, and electronic warfare equipment. But raw thrust numbers are not everything. Real-world operational value depends on durability, maintenance intervals, reliability, and consistency across production engines. If engines require frequent maintenance or have reliability issues, aircraft availability drops and combat effectiveness suffers. So while the WS-15 looks impressive on paper, its real impact will depend on how well it performs over thousands of flight hours in operational units. To understand the significance, it is useful to compare the J-20A with the US F-22 Raptor. The F-22 is powered by two Pratt & Whitney F-119 engines, each producing over 156 kilonewtons of thrust with afterburner. These engines support sustained supercruise and are known for high reliability and performance. A key feature of the F-119 is thrust vectoring. The exhaust nozzles can deflect up to plus or minus 20 degrees in pitch, giving the F-22 exceptional maneuverability, especially at high angles of attack and during close-range dogfights. The F-119 has a bypass ratio of about 0.30 and an overall pressure ratio close to 26, similar to the WS-15, but with decades of operational refinement. With two WS-15 engines, the J-20A could theoretically have equal or even higher total thrust compared to the F-22. This could translate into better performance for long-range, high-speed missions, especially where range, persistence, and dash speed matter more than close-in maneuvering. However, the current WS-15 engines appear to use non-vectoring nozzles. This gives the F-22 a major advantage in agility, post-stall maneuvering, and high angle of attack control. So while the J-20A with WS-15 could be very fast and capable in long-range missions, the F-22 likely still holds an edge in close-range dogfighting and extreme maneuverability. Overall, this development is a big milestone for China's aerospace industry. It shows that China is getting closer to fielding a fully mature fifth-generation fighter with a domestically developed high-performance engine. The real question now is how reliable and durable the WS-15 will be in everyday service, and how quickly China can scale up production across the J-20 fleet. If the WS-15 proves reliable, the J-20A could become a much more formidable platform, especially in long-range operations, air superiority patrols, and strategic missions in the Pacific region. But until the engine proves itself over many years of operational use, the F-22 and its proven propulsion system will still be considered the benchmark. Subscribe me for more updates and commenting to show your opinion.